Welcome to section 2.3 on models and applications. Oftentimes when we're working with application problems, we need to translate phrases into mathematical operations and mathematical symbols. There are certain phrases that we associate with certain operations. For example, words like increased, sum, and more than we associate with the operation of addition. Words like decreased, less than a number, we associate with subtraction. Now, phrases like twice a number or triple a number means we're taking a number, multiplying by 2 or 3. Another way we associate phrases with multiplication is words such as product, or just simply saying of. So for example, the product of 4 on a number is 4 times some number x. A quarter of a number would be 1/4 times x. Lastly, from verbal phrases, we can make equations. The key word for an equation is the word is. The is representative of the equal sign. So 4 times a number is the number increased by 2, which means 4 times a number equals the number increased by 2, or 4x equals x plus 2. Now we're going to translate the following phrases into either expressions or equations. The first example, the quotient of a number and the number plus 10 is 3 times the number. The first thing I notice is the word is. The is tells me I'm dealing with an equation. Next is the word quotient. Quotient we associate with division. Now, what are we taking the quotient of? A number and the number plus 10. What would we translate that first part of the statement? Well, the quotient of a number and the number plus 10 would translate to x over x plus 10. Is would be the equal. What's going to be on the left-hand side? 3 times the number. So we would have 3x. So our phrase translates to x over x plus 10 equals 3x. For the next example, the product of 3 times a number and the number decreased by 2 is 5. First, what jumps out is the word is. Remember, is represents the equal sign, so we are writing an equation. Now, what would be the right-hand side of the equation? Well, that would be 5. So let's go ahead and write that down in our equation, since that's pretty quick and easy to translate. Looking at before the is, that would be the left-hand side of our equation. What operation should we start with? Well, we have a product. Product, remember, means multiplication. Now, what are we multiplying? The 3 times a number and the number decreased by 2. Well, 3 times a number is 3x. The number decreased by 2 would be x minus 2. And notice here how I'm keeping parentheses around the x minus 2, because I'm multiplying the expression 3x with x minus 2. So I need those parentheses to indicate that. So my phrase translates to 3x times x minus 2 equals 5. In this problem here, we're going to look at how linear models can help us solve word problems and real-life problems. When looking at a word problem, the hardest part is to keep information organized. A linear model can help us keep that information organized by taking the various information, trying to form equations out of it, and that will give us a nice compact summary of the problem. And then from there, we can use that equation or equations to help us solve any other questions that are asked of us. Example 2. There are 2 cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 5 cents per minute. Company B charges a monthly service fee of $40 plus 4 cents per minute talk time. First, we want to write a linear equation that models the package offered from both companies. In this problem here, we should name our variables. We're going to make C equal the cost of the package and T equal the talk time. So for company A, what would be our equation? Well, our cost is, so cost equals, well, they tell us that we have a service fee of $34 per month. So no matter what, we have to pay $34. They also charge us 5 cents per minute. We'll add 0.05 times how much time we talk, which is T. So our linear equation that models package A is C equals 34 plus 0.5 T. For company B, they charge $40 per month with a 4 cent per minute talk time. It would be the cost C equals, well, we always have to pay the $40 in this plan. Then we're charged per minute 4 cents, so 0.04 times T. Now that we have this information, it's going to make answering the rest of these problems a little bit easier. If the average number of minutes used each month is 1,160, which company offers the better plan? Since we have the model for each plan, all we have to do is take our value of time, which here, according to the problem, the time would be 1,160, and plug it into the 2 equations. Now, we want the better plan. Well, it's best if we spend the less amount of money. So whichever plan requires us to spend the least will be the better plan. So one at a time, we'll take our T of 1,160 and plug it into each equation. For our company A, cost is 34 plus 0.05 times 1,160. And if we work out the arithmetic, we get that the cost is $92. The same thing for plan B. Take our T, plug it into the equation. So we have that our cost equals 40 plus 0.04 times 1,160. And when we work out the arithmetic, we get $86.40. So again, the best deal is the one that requires us to spend the least amount of money? Well, the 86.4 is smaller than 92. So if we're speaking 1,160 minutes per month, plan B would be the best deal. Now, suppose that the average number of minutes used each month is 420. Which company offers the better deal then? Here, our T is 420. Just like what we did in the previous part, we'll plug 420 for T in both equations. First, for plan A, our cost would equal $55. For plan B, our cost would be $56.80. Which is the better deal? Plan A only charges us $55, while plan B charges us more money with $56.8. So if we're only speaking 420 minutes per month, plan A is the better deal. Lastly, how many minutes of talk time would yield equal monthly statements from both companies? So in this part, we want the cost of company A's plan to equal the cost of company B's plan. 34 plus 0.05t have to equal plan B's cost, which is 40 plus 0.04t. Now we have a linear equation to solve, so we'll use the strategies we learned in the previous section. Subtract 0.04t from both sides, and we'll also subtract 34 from both sides. On the left-hand side, the 34's cancel. Collect our like terms with the t. We get 0.01t equals, on the right-hand side, the 0.04t's cancel. Collect our like terms, 40 minus 34 is 6. Then divide both sides by 0.01, and we get t equals 600. So we would have to speak for 600 minutes in order for both plans to have the same cost. Let's take a look at a problem involving geometry. In example 3, the perimeter of a rectangular outdoor patio is 210 feet. The length is 10 feet greater than the width. What are the dimensions of the patio? When it comes to geometry problems, it helps to draw a picture. So we'll draw a rectangle to help us visualize the shape. Now, how do we name our variables to start setting up our equations? In this problem here, notice how it says the length is 10 feet greater than the width. If we make L the length, W the width, we're told by this statement, the length L is, well, 10 feet greater than the width. Well, greater we would associate with addition. Length would be W plus 10. So let's go ahead and fill that information in our diagram. I'll name the vertical sides the width, and remember, with rectangles, opposite sides are the same length. The horizontal sides will make the length, which we just determined to be W plus 10 units long. Now, what other information can we get from the problem? Well, we're told that the perimeter of the rectangle is 210 feet. The perimeter is the sum of the length of the sides of the rectangle, or any polygon for that matter. So the perimeter would be W for one side, W for the other, plus W plus 10 for the one length, W plus 10 for the other length. Our perimeter, we're told, is 210 feet. Now, with this information, we just formed a linear equation, which we can solve. On the right-hand side, we can collect our like terms. We see we have W plus W plus W plus W, which is 4W, and we have the 10 plus 10, which is 20. We'll subtract 20 from both sides. We get 4W equals 190. Divide by 4, and we get W equals 47.5. One thing to be careful of when answering word problems is just because you found the variable doesn't necessarily mean you've answered the question. The question asks for the dimensions of the patio, which means we need to know the width and we need to know the length. From our work, W represented the width. So we know the width of the patio is 47.5. Now we need to find the length. Well, earlier, we found that the length was W plus 10. Now that we know that W is 47.5, let's go ahead and plug that in. And when we add, we get 57.5. So what is our answer? Well, our patio is 47.5. Well, 0.5 what? Since our perimeter is measured in feet and we're told that the length is 10 feet greater, then this 47.5 is measured in feet. You do want to remember your units. I, what's its length? 57.5 feet. So remember, with any word problem, after you solve for a variable, go back and double check the question, make sure you've answered it, and also make sure you remember to include any units that you see in the problem. In this next example, we're going to work with a trapezoid. The area of the trapezoid can be found with the following formula. A equals H times B1 plus B2 all over 2. A represents the area, B1 and B2 represent the length of the bases, which are the two sides parallel in the trapezoid, and H represents the height, which is the distance between the two bases. In the first part, what is the area when the height of the trapezoid is 5 yards and the length of its bases are 5 yards and 9 yards? Well, in this problem here, we can just go ahead and take our values and plug it right into the formula we see above. Our A will equal H is 5, our B1 is 5, our B2 is 9, and all over 2, which comes from the formula. Now, if we work out our order of operations or use a calculator, the area is 35. Now, what would be the units? Our units would be yards squared. In some circumstances, we may not want to find the area. We may know what the area and the length of the bases are, But from that, we want to figure out what the height of the trapezoid would have to be. If we have to do this several times, it would be very cumbersome to just take the values of a, b1, and b2, plug it in, and then solve for h over and over again. So what we're going to do here is we're going to manipulate our area formula as we have it now and try to solve for h. In other words, we're going to try to isolate h, similar to how we have a isolated in our formula now. So starting off with our formula, our goal is we're trying to isolate h. Now let's think about how we would simplify h times b1 plus b2 over 2. First, we would do b1 plus b2, multiply that with h, and then divide the whole thing by 2. Well, if we're going to solve for h, I want to do the complete reverse to get h by itself. So the first thing I would do is get rid of the division by 2, since that's the last operation we would perform. The way we would get rid of division is we would multiply both sides by 2. So the left-hand side, we get 2a equals, and it's going to leave h with b1 plus b2. Now from there, we have h times b1 plus b2. How do we get the h by itself? Well, h is being multiplied to b1 plus b2. So to isolate h, we're going to divide by b1 plus b2. Even though b1, b2 are variables, they do represent numbers. So we can divide by b1 plus b2. Remember, we do have to divide both sides by b1 plus b2. For our left-hand side, there's nothing to simplify. We'll just keep it as 2a over b1 plus b2. Our right-hand side, the b1 plus b2s are going to cancel, leaving us with h. So there's our formula for h, where if I know the area and the length of the two bases, I can find the height of the trapezoid. Now that we have h solved for, let's answer these two questions, which look very similar, just with different numbers. First, what is the height of the trapezoid if b1 equals 5 yards, b2 is 9 yards, and the area is 28 square yards? Out having our formula from the previous part, we would have to take the 5, the 9, and the 28, plug it in to our area formula, and then solve for h. Now, doing that once isn't too bad. If you have to do it 2, 3, 4 times, it does get a bit tiring and cumbersome. Fortunately for us, we've already done the work of isolating h. Since we have h already isolated in the previous part, all we have to do is take our values for a, b1, and b2 and plug them into our formula above. Now that our values are plugged in, we can follow order of operations, and we get that the height is 4, and our units would be yards, since our bases are measured in yards and our area is measured in yards squared. And we can also quickly answer the second part, where we want to find the height where our first base is 6 yards, the second base is 10 yards, and the area is 48 square yards. Again, using the formula for h that we found in the previous part, h will equal 2 times our area, 48, divided by 6 plus 10. And if we work out the arithmetic, we get that the height is 6 yards. Example here, we're going to take a look at consecutive integers. Consecutive integers are integers that come one after the other. So for example, 1 and 2 are consecutive integers. 2 comes after 1, 1 comes before 2. 10 and 11 are consecutive integers. Negative 53 and negative 54 are consecutive integers, so on and so forth. Now in this problem here, we're told the sum of 4 consecutive integers is 1,226. What are the 4 integers? To start, how do we represent the 4 consecutive integers? Well, we're going to start off with n as our first integer. You can use n or x. For integers, we like to use n. Now, how would we get the next integer? Well, the next integer, we would add 1. So for example, if I start with 0, if I want to know what comes after it, I just add 1 to get 1. So if I start with n, the next integer would be n plus 1. Now I have 2 consecutive integers, but I still need 4. Well, how do I find the next one? Well, I add 1 again. I get n plus 2. Well, I need 4 consecutive integers, so I'm going to add 1 again. I get n plus 3. So my 4 consecutive integers is n plus 1, n plus 2, and n plus 3. In the problem, I'm told the sum is 1,226. So if I add my 4 integers together, n plus n plus 1 plus n plus 2 plus n plus 3, that equals 1,226. Now I made a linear equation. We can go ahead and solve. And we get n equals 305. Now again, we have to be careful with the question. They ask, what are the 4 integers? N represents our first integer. First integer is 305. What would be the next one? That would be 306. Our third integer is 307. Our fourth integer would be 308. And there's our 4 consecutive integers, whose sum is 1,226. Now in this problem, the sum of 3 consecutive even integers is 384. What are the 3 integers? Now with this problem here, we have to be careful on what it means to be an even integer. Even numbers are numbers like 2, 4, 6, 8, 10, so on and so forth. Even numbers are divisible by 2. In order to represent an even number, we'll represent it as 2n, 2 times some number, because all even numbers can be written as 2 times something. Now, if my first even integer is 2n, what would be the even integer that comes after it? Now, if we take the idea of consecutive integers, we would think, well, if I add 1, that would be the next integer. However, we have to be careful here. We want consecutive even integers. Would 2n plus 1 be even? Well, no. Think of it this way. If we started with 6, if I add 1, I get 7, which is odd. So I don't want to add 1. To get my next even integer, what we're going to add instead is 2. because every other integer is even. So far, I have 2n and 2n plus 2 as two consecutive even integers. I do want 3. So I'm going to add 2 again, and I get 2n plus 4. According to the problem, we're told the sum is 384. So the sum means we're adding the numbers together. So 2n plus 2n plus 2 plus 2n plus 4 equals 384. Now we have our linear equation. Let's solve. And we get n equals 63. Now, even though we have n, we have not yet answered the question. What are the three integers? Now, the first integer is 2n, and we just found n to equal 63, and 2 times 63 is 126. So our first of our three even integers is 126. So what would be our next even integer? Well, 2n plus 2, add 2 to what we have before, we get 128. And for our third integer, add 2 again, we get 130. In this next example, we're going to look at consecutive odd integers. In this problem, we're told the sum of two consecutive odd integers is negative 272. What are the two integers? So first, what are consecutive odd integers? Well, odd integers are any integers that are not divisible by 2, numbers such as 1, 3, 5, 9, and 7. From before, in the last example, we know we can write any even integer as 2 times another integer. Odd integers always come after an even integer. So if 2n is even, then if I add 1, I get 2n plus 1, which is an odd integer because it comes after the even integer 2n. So that will be my first odd integer. How do I get my second odd integer? Well, if I add 1, I get 2n plus 2, which we saw before was an even integer. And the pattern for integers is even, odd, even, odd. So if I add 1 to an odd integer, I get an even integer. So I want to skip that even integer. The way I'll skip that even integer is I'll add 2 instead. When I add 2 to 2n plus 1, I get 2n plus 3. Now I'm told the sum of my two consecutive odd integers is negative 272. Well, sum means addition. So 2n plus 1 plus 2n plus 3 equals negative 272. Now I have an equation to solve, and we get n equals negative 69. But remember, just like the other questions, just because we found n doesn't mean we've answered the question. They want to know what are our two integers. Well, with n being negative 69, 2n plus 1, our first odd integer, that's going to equal 2 times negative 69 plus 1, which will equal negative 137, which is indeed an odd integer. So what would be our next odd integer? The 2n plus 3. Well, if we add 2 to our negative 137, we get negative 135. The two consecutive odd integers whose sum is negative 272, it's negative 137, negative 135.